Hey guys, welcome for data science. So I have Rohin and Rohan with me today, and these guys have done a data science project on AutoML basically, and we planned for a live session on this, but we thought let's record it and put it so that everybody can get benefited later as well. Okay, so these guys are going to give us demo of what work they have done on AutoML and how they have executed their project, front end, back end, everything. And then obviously, if any doubts, any questions, any further discussions is needed, drop me a comment and I will just respond to you. All these guys will also be there in the comments. So let's start, guys. Over to Rohin.
Yeah, actually, hello everyone. I'm Rohan, currently pursuing final year in BSc. So that is Rohan. So we have done an amazing project on machine learning. So let me share my screen. Let's go to the project.
Sure, it's loading. Yeah, we can see your screen, Rohin.
Yeah. So this is our web page which we have done. So first let us see how this works and further go to our project.
Sure.
So for example, let me paste an URL of a raw CSV file or any other TSP or .txt file in this text box.
Okay.
So here I have a sample data set. So let us copy this and paste it in the text box. So and we should select the type of problem, whether it is a classification or a regression. So as it is regression, we go for regression. So let us click on get model.
Okay. And it's executing in the background, right?
Yeah.
Okay.
So yeah, now we have got the best model and best features. So in this, so this is our project. If we give any raw data set, it runs an automated machine learning process like data processing and feature engineering and finally model building and give us best parameters and best features. So here we can see the best model is a random forest regressor of n estimators of 200 and best feature is radio and TV.
Okay.
So this is our project and let us go into it. So how we have done it.
So what it does basically is it will take one data set and you have to tell whether it's classification or regression and
type
it will
of
tell
problem
you.
statement and it will tell us which model is the best and it gives us a best parameter and it gives the best features of it.
Okay, so we are going to see more details of what logic goes behind. Yeah.
Yeah.
So Rohan, would you be sharing your screen on that and explaining few stuff? Rohan, you're on mute, Rohan.
Rohan?
Kindly unmute yourself. Yeah, now you are unmuted.
Okay.
Yeah. Fine. We can see the first slide, AutoML slide.
Rohan, go through.
If you want, you can switch off your camera, not needed.
Are you sharing it?
If that takes your bandwidth, you can switch off your camera.
Is my voice
clear
now?
Further.
Yeah, your voice is
further. Rohan will continue.
Rohan, shall I share screen or will you?
Yeah, I'll share my screen.
You will share. Okay. AutoML. Automate the most time-consuming steps in data science project. Next slide, please. And why we need to use AutoML? But to answer this question, let us look at the life cycle of a data science project and time it consumes in each stage of it. For data collection, loading, and cleaning, it takes about 45% of total time of the project. And for visualization, it takes 21%. And for model selection and feature selection process, it takes nearly about 11% of time. And for model training and hyperparameter tuning, it takes about 12%. And for deploying, it takes about 11%. And these are the steps we will be following in each data science project. What if we automate the most time-consuming steps? We save a lot of time, right? By using AutoML, we can save up to 68% of time. All you need to have to use AutoML is that you need to have the URL of the dataset. It need not necessarily from your GitHub repository. It can be from any GitHub repository. So now you have the dataset and you can use the AutoML. By using AutoML, you can automate the process like data loading and cleaning, model selection, model training, and hyperparameter tuning. And when you add these percentages, 45 plus 11 plus 12, it sums up to 68%, which is the amount of time you save. Next. And next question rises, how to use AutoML? To use AutoML, you just need a URL of the data set and you have to choose the problem type of the problem type you are looking for solve. It's either regression or classification. And when you hit the get model button, you will get the best model, best parameters, and the best features. It is that simple. Next. And what are the things you can perform by using AutoML? You can either perform regression task or classification task. We use regression to predict a continuous valid outcome, or when the target variable is continuous, we use regression to predict its values. For example, in flight floor prediction, we will be predicting the cost of the ticket, which is a continuous variable. So we use regression to solve that particular use case. And if you look at how it was implemented, we have used 4 classes in that. The first class is data process, and then outlier removal, feature engineering and selection, and model build. Next one. And for classification, the main aim of classification is to determine which category an observation belongs to. For example, if we take a spam detection, we categorize our email into either spam or it is not spam. We categorize only into these 2 sets. And for classification, examples goes on like whether a patient has a diabetes or not, or heart disease or not, and the list goes on. And in here, for classification, we have used 4 classes called data process, outlier removal, feature selection, and model building. The same 4 classes we have used here.
So classes in common. So in class in common, there are 2 classes. One is the data process and outlier removal. So let's see one by one. So in
classes,
data process.
One moment. Class, what are you talking about? Python classes?
Yeah, Python classes.
Yes. So you are going into coding level details. Okay, fine. Yeah, go ahead.
Yeah. So in data process method, classes, we have 3 methods. One is get df, and second is nan threshold, and another one is get x and y. So let's see one by one. So in get df method, we collect the first we will collect the URL from the input, and it reads the data set, and it reads the data set whether it is in a TSP file or CSV file or XML file, anything. It can read this different files, different file format. So second is nan threshold. So let's see nan threshold. So if a column contains more than 40% of nan threshold, then our method will remove the column from the data set. So this is how we programmed it. So we can make it the 40% as any values. So whether if a non value is more than 40% in a data set, then the column has no use. So we have programmed like taking off it, whether if it is 40%, more than 40%. So another is get x and y. So in a data frame, we will split the data set, total data set into x and y. So y is a target variable where we have programmed like last column is as a target variable, and we separate it into y variable and other features as x variable. Yeah, that's what the data processing is. So second class is outlier removal. So it will be explained by Rohan.
Yeah, outlier removal. After we separate features and target, now our aim is to take care of the outlier in it. To do that, we use 4 methods inside outlier removal class by which we can handle outliers and missing values. Next slide. Impute NA. This method is used to fill the missing values in the dataset. If the variable is continuous, then we will use iterative imputer, like iterative imputer. As a feature 1 is a continuous variable, we use iterative imputer to fill the NaN values in it. And if the feature is categorical, we use simple imputer to fill the value. And how iterative imputer works just like a regression model. It takes the value, it takes a feature 1 as a target and remaining all columns as features, and it starts predicting the missing value in the feature 1. And simple imputer just fills the most repeated value. So here that's has been replaced and outlier continue. We will separate the continuous features into normally distributed or not normally distributed. First, if the feature is normally distributed, when we plot them, we will get a bell-shaped curve. If it is not normally distributed, when we plot them, we can't get any bell-shaped curve in it. If a feature follows normal distribution, we can remove outlier. We can remove outlier by only by considering the 3 standard deviation from its mean. That's what this normal outlier function does. Next one. If feature is not normally distributed, then we can use a pure method or interquartile range to remove the outlier from the data set. This is what the not normal outlier function does. Now we have handled the missing values and we have also removed outliers. The next step is feature selection. Rohan, over to you.
Yeah, feature selection, feature engineering and selection. So first is zero. We have 8 methods. One is zero variance and continuous correlation with variables, and continuous correlation with target and mutual incorporation. Then we have top 10 categorical values and ordinal encode, categorical correlation with target, and encoding with encoding and scaling. So let's see one by one. Zero variance. This is a method in feature engineering. First method in feature engineering. So if a feature contains similar values in every row, then it will be removed. Why? Because it has no mean in having every values as same. So it will automatically remove the column which has zero variance. So next one is constant correlation with features. So actually we will calculate the correlation with features in continuous columns. So if the features, if the correlation is above 80%, above 80, 0.80, then we will consider and fed into the next part. So if it is below than 80, then we will take the feature outside the data frame. So that's what we have programmed this. So then next is constant correlation with target. So as I said before, correlation with the correlation with the features, it relates to with target also. So we only change the threshold value as 0.30. If it is above 0.30, then we will remove the feature.
You will remove or you will keep?
Actually, we will keep it.
Features. So that's what. If the feature values is greater than increases with the target value, then the correlation will be positive. So if both one increases and one decreases, then it will be negative value.
So when you say 0.3, it is magnitude. It is not direction, right?
Pardon?
When you say 0.3, you are talking about magnitude, not the direction.
Yeah, actually, if it is about 0.30, then we will consider fed into next process. So if it is below than 0.30, then we will remove from the data frame.
So if you are, what correlation you are computing?
Continuous correlation with target variable.
And what method goes inside? I mean, is it Pearson correlation or what kind of correlation?
Yeah, it is Spearman correlation.
Okay. Is that what is your target variable here?
Target variable, as I said before, in data processing, first method is to separate the target variable as x and y. It separates. Yeah, this is an automatic process, so it separates the x and y in the first process, processing method. So after that, we will come to feature engineering and selection class.
Okay.
So
go
yeah,
ahead.
that's our process.
And yes, here we will compute a mutual info regression, which is available in sklearn. The use of mutual info regression, it is applicable for a regression problem. It is used to measure the dependency between the variables, and we will consider only the top features in this group. As you can see the graph, we will consider only the top features in this group. Next slide, please. If it was a classification problem, then we would have used mutual info classif method, and we use mutual info classif to measure the dependencies between the variable, and we only consider the top features in this graph. Next one. And top 10 categorical values. If a categorical variable contains more than 10 categories in it, we will choose the top most repeated item in them, because while performing one-hot encoding, it could lead to a curse of dimensionality problem where there will be more number of features. Then here we perform ordinal encoding for categorical variables, and what it does, it converts categorical values into numeric values for every entry in it goes first it looks at the apple. It was a unique entry, so it back please. First it looks at the apple. It was a unique entry, so it has marked as 1. Then it looks at banana. It was second. It was a unique again, so 2. And orange, it was unique again, 3. Now again it's banana, so it goes and fetches a value assigned previously to it, and it was 2. An apple, again it goes and fetches a value assigned to it previously, and it marks it as 1. Next one. And here, Roy?
Yeah, categorical correlation with target. So it calculates the correlation with target for categorical columns, as I said before. So here we have given a threshold value as 0.20. When if the when the value is above 0.20, then it fed the data into other next process. So this is how we have programmed this categorical correlation with target in categories. So this works in categories. So next slide. Encoding.
Here we will perform encoding and scaling of features. After selecting the best features, we will encode the categorical values and scale down the continuous values. And for encoding categorical values, we use one-hot encoding. For every unique values in the feature 2, we will create that much number of columns. And if the first entry is apple, then it will go to the respective column and it will mark it as 1 and remaining entries as 0. And this process follows for all the unique entries in the feature 2. Next. And for scaling, we use standard scaler. It scales down to its mean where it is 0, and from mean it will be considered 3 standard deviation. As in the outlier removal process, we have considered only 3 standard deviation. All its values will be below minus 3. Next one.
So model building. First method is get best model. So actually in model building we have only one method. So get best model. Let's go into. So we have divided this model into 2 parts. One is train test bed and model building. So firstly, as we after feature engineering and selection, we have the outcome will be the total data set. So from this total data set, there will be X and Y. X features will contains other features and target variable. So this is this is actually EDA process have been already done. So in this train test bed, as usual, normal train test bed, we will split these features into 80% training data and 20% test data. So that's how we split this. But also we can program like 70% train data and 30% test data as however we can. That one?
Yes. Now we got the training data set. Now we will fit this training data set into the machine learning model. Here we have used a randomized search CV method where it contains all, if it was a regression problem, that it will be containing all regression algorithms available. And if it was a classification, then it will be having all the classification algorithms lined up with hyperparameters.
Will you show the code to us?
You're asking
Sure,
for
sir.
code, right?
Yeah.
Rohan?
Yeah. I shall.
Because I feel it will be better if you explain from the code rather from the slides.
Yeah, one sec. I will share the screen.
Yeah.
So is this visible?
Yes, visible. From the code you
So
can walk through. Yeah.
Yeah, so this is the main file app.py.
So you can just tell high level what this file does and what are different. What app.py was?
So first we have imported the library packages. So this is an automl classification file. So first, as we said, first class is data preprocessing method, and we used three methods. One is get df, and another is an unthreshold.
That is what we
And
explained.
and get x and y. So we have explained in that before, as we explained before. So next class is outlier removal. So in this outlier removal, we used first class is input none, yeah, 4 classes, and first is outlier removal and outlier continuous. So these are the 4 classes. So in feature engineering, we have 8 classes. Sorry, 8 methods.
Hold on. In outlier removal, how are you saying that something is normally distributed or not normally distributed? How are you saying that? Which test are you running?
Just pause here. Outlier removal. Right?
Yeah, outlier removal. Yes.
Go to the method called outlier removal.
I'm saying Safiro test you are running or something.
Right? You got it?
Yeah, I am on screen.
Go down.
Go down, right?
Okay. Input none, right?
Input none or whatever.
Line 171. Line number 171. Just
yeah. Okay. Yeah.
Yes, sir.
So what my question here is, you are saying you are taking two different approaches for outlier. One if it is normally distributed, other if it is not normally distributed. So my question to you is, how are you deciding what normally distributed and what is not normally distributed?
Yes, sir. We will be running a statistical test here called a Shapiro method, and we will calculate its p-value. If it is greater than this threshold 0.05, this is threshold we use normally. And if it is greater than p-value is greater than that, we will be storing in the normally distributed dictionary. And if it is not normal, we will be storing it in the not normally distributed dictionary.
Okay, got it. That is what I was asking.
Yes.
Go ahead to your feature engineering class.
Yeah, this is a feature engineering class. So here we have used 8 methods.
Okay.
One is zero variance. First one is zero variance, as we explained before. So next is correlation method, correlation with the continuous features. So then mutual info, then correlation of with target variable. So then top 10 categorical values, ordinal encoding.
Okay.
Target variable, then full ordinal encoding.
Okay.
So these are the feature engineering techniques we have used.
Fine. Where are you running the model?
Actually, we have deployed this project in Heroku.
No. My question is different.
Line number 559, right?
Yes, line number 559, and you are passing.
Yeah, okay. Model building, right?
Okay, shall I proceed, Rohit?
Yeah, okay. Go through.
Just go top. Just make it as 551 as the first line, so you can see the full amount of code.
551.
559, right?
Yeah, okay.
Class build model.
Yes, sir. In the constructor of a build model, we will be getting the X as the features and we target Y. And here we will train test split, and the split is about 75% is for training and 25 is for testing. And now we will call a method called get bus model. 581, go to this method. Move on.
Yeah.
Yeah, just pause here. Hey,
Yeah.
show me the parameter grid.
Yeah. Okay. Okay.
Params grid. And the first model will be SVM. It's just like a dictionary, nested dictionary. We have used nested dictionary. The first model is SVM, and the model, and this is where we create a object for the SVM, SPC classifier, supported classifier, and the parameters in the parameter grid we will give the gamma value as auto scale for C 1 2 3 for kernel RBF or either linear, and for a random forest we will create a random forest classifier object here. And for the parameter list, we use n estimators in this range from 100 to 375, skipping by 25, 25. Just come down, Ada boost. Right, move down. And for Ada boost, we have created Ada boost object of an Ada boost here. And for the hyperparameters, we have used n estimators from ranging 100 to 275 by 20, 25, 25.
So for different models, you are giving different parameters. Whatever
Yes,
you give is making sense here, right?
Yes.
Okay.
And the learning rate is about and this process goes on for gradient descent. We will be creating a model, a gradient descent object, and possible hyperparameters for XGBoost, for KN, and bagging classifier decision tree. Just move on. And Gaussian naive base, and the only possible thing is the vast smoothing. And here's what the model is getting trained in line number 659. It just loops through the parameter grid, which I have said before, the nested dictionary. Just loops through the nested dictionary. You will get the parameter name. If you look at the 650, the Gaussian NB, it will be stored in the model name, and remaining model parameters, remaining dictionary will be stored in the model params. And we will be running a git search CV. The model, it goes and picks up the model, which is a Gaussian naive object, and model parameters, which is the possible hyperparameters, and we will be running n iteration as twos. If you want, we can increase the number of iteration we need to run over this hyperparameters. We have chose here to run 2, and if you want to increase cost validation, we can increase it to some higher scores. We have choose tier 5. Okay. And once now we are initialized the model, which is model name, then we will fit it with the X train and the Y train, and we predict X test, we will get the Y predicted, and we will do some metric accuracy test. It'll give you the score, and we will print it out. And these print statements are just for debugging purpose.
Right. So you are storing everything in a pandas data frame, and then you may be sorting and displaying it, right?
Yes.
Okay. Now how you are using it in the Heroku? How you are deploying it?
Yeah. We are deployed in a Heroku by using a proc file. To deploy in Heroku, first we have uploaded all these files in our GitHub repository, and and a proc file architecture, and we will and upload a proc file on that. Sir, hello.
Proc file. Show it.
Yes, sir. Rohan, open the proc file. Yeah, you can use this is app.py. First one is app.py, the driver class where we will running these files. From the app.py, we will call all these methods, and this is the second app, which is the name. We just go to the app.py. Rohan? Hello, am I audible?
Yes, you are audible.
Yeah, you are audible.
Yeah.
Sorry, my internet connection.
Go to app.py.
Yeah, one second.
Just move on to top.
Yeah, fine.
Yeah, we have used Flask as a background. Here we have imported all the classes for AutoML classification and regression, and including the forms. Yeah, we have initiated the Flask. This is app. In line number 21, you can see the app equal to Flask name. We initialized Twitter and just scroll down. Straight. Yeah, app.route, line number 35. In app.route, in home route, we will be rendering this template. Just go below. Go down.
Scroll down once. Yeah.
Scroll down once. Once we click into the home route, this line number 73 will be executed, and it will be the template will be rendered, and then it goes. And when the form submission happens, the control moves on to put up. Rohan?
Hello, Rohin, can you hear us?
Hello, am I audible?
Now you are audible.
Hello?
Yeah, hello.
Hello, Rohan?
Yeah, Ron,
Yeah.
tell me.
Just go for the home route. Yeah, just stop here. Okay. Home route.
Home room. Pardon?
Scroll top. Go to top. Yes. Yeah, stop here.
Okay.
Hey, scroll down now.
Okay.
Stop in the line number 34.
Yeah, okay.
Yeah, once the form is line number over to the line number 42. Once the form is get submitted, we will. Okay, once the form is submitted, we will get the form values, and if it was a problem type was classification, then we will call the data process class in the classification file, and we'll pass the URL the user have passed and the problem type given. And now it goes on. It does all the activity. It runs all 4 classes, and it will return the best model. And here the parameters to display, it gets this is why it gets the best model parameters as a data frame, and from that we will as a model name we will get the, hey, we are doing indexing here, and we'll get the model name and the best parameter, and the features will be in all these 3 steps. First we will get the model name and the best score and the feature, and we will render the template by we will pass this model name as model name, this parameters, and it goes on to the templates where a template called index.html. Through Jinja 2 template, we will be displaying those values in the front end.
Okay, got it. Anything else that you want to explain? Anything else that you want to put here?
Rohan, is there anything?
Pardon, sir?
Anything else that you want to cover?
Yeah, this is our project. So
okay, have you posted the code somewhere on Git?
Yeah, we have posted our project on GitHub.
Is it public?
Yeah, of course.
Yes,
it is
sir.
public. I can share the link. Both of them.
Okay, good.
So here is our project, automated ML.
We can't see your screen. I mean, it is not changing. To share the entire screen, I think we have shared one window.
Is it possible visible now?
Now I can see. Yeah.
Yeah, this is our repository.
Okay. Mm-hmm.
So we have deployed in Heroku.
Mm-hmm.
Yeah.
Okay. Okay, fine. So I will give this link to the audience. Maybe they want to go through and they want to ask something to you. Okay. And I will
Yeah,
give your
sure.
mail IDs also. If you are
Yeah,
on
sure.
LinkedIn, then your LinkedIn ID also. Okay.
Yeah, sure. Then
So
if
you
any
can
queries or
any
doubts,
queries,
then viewers can ping us on LinkedIn or mail ID.
sure, no problem. And thanks for the amazing session, guys. And I understand there was some arrangement issues. So what I will say is, whenever you are giving presentation, don't keep so many slides. Okay. What I saw is you guys have kept like 70, 80 slides. Every slide is
Okay.
one method. So keep your slides short and crisp. Don't put many slides. Okay. And try to create a story, because if you realize, you directly started taking me to the code, taking me to the methods without even saying what is the methods in PPT, right? Then I asked you
Yes, sir.
what are you talking about. So what I'm saying you is, I will tell you in case you are not getting my idea. Can you see my whiteboard?
Yeah, yeah.
Yes, sir.
So every time you are presenting something to someone, right? It has to be a story.
Okay.
Okay, so story should start from something at high level. Okay, this can be your high level thing. So if I were in your team to prepare this presentation, right? So what I will
Okay.
do is, I will first talk high level. High level means your first step was good. Your first step was showing me the demo things, right? I mean, you took me to the home screen
Yes, sir.
and showed what it does. That was good. Then second thing, what you could have done is, you could have told, this has been done using Python, and in Python this has been done using object oriented concept of Python. So there are multiple things involved. We have written some classes. Inside the classes we have written some methods. Okay, and all these methods we are calling, we are using Flask app here, we are calling through that app. Okay, and
Okay.
then what you would have done at third step is, you would have put all or most of the methods in a one slide or two slide or three slide PPT maximum. Okay, no need to give name of the method and all. Okay, you can
Yeah.
just say method 1 does this, method 2 does this, method 3 does this. Like this you can show in 2 3 slides. Okay, and
Yeah.
you can say, then we will be calling these methods. Then you go to step 4 and you can say, I will show you the detailed code for this assignment here, and you can walk through the code, not in very detail, but just like we discussed now, right? So the method does this is our main class, this is our sub class, this is our this method. So what I'm saying here is, expect users to ask questions. Then that way your presentation will be more engaging and more beneficial for everyone. Okay.
Yeah,
So
sure.
when you go to code and when you explain, people will ask you questions. And in the fifth slide, or not fifth slide, fifth part of the presentation, you can just show the entire end-to-end thing once from coding point of view. Okay, and then go back to your step 1 and show, this is how I'm consuming the input and this is how I'm giving the output. Now if you have any questions, you can ask me. So what I'm saying, go like a flow and try to create a story, and try to maintain the audience interest throughout the journey. Okay, what
Yeah, sure.
happens if you start showing more slides, right? Audience might get bored. If you start showing more code, audience might get bored. So make it more engaging and make it more what to say, presentable.
Yeah, sure.
Apart from that, your work is good, and I can see a lot of effort you have put in preparing the presentation, which is also good. Okay, so you guys are very young now, you are students, so you will not be able to very, very industry standard presentation you won't be able to do now, but just some high level things I give. Because when you tomorrow go and work in a company, right, you will be presentation to big people, and they don't have a lot of time. So you will be told to tell everything in like 15 minutes. Okay. So you should develop the art of utilizing this in best possible way.
Yeah, sure.
Yes.
You got my message?
Yeah, sure.
Yes, sir.
So, but I really appreciate the work you guys have done and also the effort you have in the presentation. Okay.
Yeah, thank you so much.
Thank you, sir.
So thanks for joining and stay in touch, guys. And Rohan, I will mail you. I will talk to you. Rohan, I will mail you also. Okay.
Yeah, sure.
Yes, sir.
Thank you so much for your time.
Thank you, sir.
Thank you, sir. Thank you for this opportunity, sir.
Thank you for this.
Thank you.
Thank you, sir.
Yeah.